In this video, we're going to talk about finding rational and real zeros, and we're going to introduce the idea of multiplicity. So it's example 1. We're given the function f of x equals x minus 1, x minus 2, and x minus 3. We know if we were to solve this, our zeros would be 1, 2, and 3. If we look at g of x, we have x minus 1, x minus 3, x minus 3. So we have zeros at 1, 3, and 3. Since the 3 is repeated, we call that a multiplicity of 2. The 1's not repeated, so it has a multiplicity of 1. In f of x, none of the zeros are repeated, so they all have multiplicity of 1. So what does this mean? If we look at the first function, if we look at the graph, it goes to the graph at the x-axis at 1, 2, and 3. It crosses. If we look at the second graph, this would be the graph of f of x. This will be the graph of g of x. If we look at 1, it goes through, but the 3, since it's repeated, it touches the x-axis. So that's the basic idea of multiplicity. If it's a even multiplicity, it's going to touch, whereas if it's an odd multiplicity, it's going to go through the x-axis. And we are done. Example 1. We'll explore this idea more in a few more examples. Example 2. We're asked to find an equation in the graph P to the right. So we can see that we're crossing the x-axis at -4 between -2 and -1, so we can say that's approximately -3/2 or -1.5, and we're touching at 1. So our equation is going to be P of x equals x plus 4. To get to -3.5, we're going to say x plus 3/2 equals 0. We're going to multiply everything by 2 to get 2x plus 3 equals 0. So we're going to have 2x plus 3 as part of the equation. And then we have x minus 1, but since it's touching, it's have a multiplicity of 2, so we'll just raise it to a second power, and we're done. Example 2. Example 3. There are several examples involved. So first question, what are the zeros of f of x equals x plus 4, x minus 7? So our zeros are going to be x equals -4, 7. We just changed the signs. Number 2. The graph of function g crosses the x-axis at 2, 0. What must be a root of the equation g of x equals 0? So our root must be x equals 2, and we're done. The zeros of a function h are -1 and 3. What function could be h of x? So we can just say h of x equals, change the sign, x plus 1, x minus 3, and we're done. When a linear factor occurs multiple times in a factorization of a polynomial, that gives related zero multiplicity. Part 5. Which zero of f of x equals x minus 3, x minus 1 to the third power is a multiplicity of 3? We look at the exponent, so the one that has a multiplicity of 3 will be just x equals 1. 6. Which zero of g of x equals x plus 1 to the third power? 2x plus 1 squared has a double zero. It's this zero here, so double means 2, so let's just quickly work that out at the bottom. 2x plus 1 equals 0. Subtract 1, subtract 1. So we have 2x equals -1. Then we'll divide by 2. We're left with x equals -1/2. So our answer for number 6 will be x equals -1/2, and we're done. And the graph function is the multiplicity of 6 even or odd. So we're looking at this function here to the right. So since it's going through the axis there, we're going to say it's odd. Now in general, if a function f has an odd multiplicity, the graph of y equals f of x will cross the x-axis, like we see in this function here on the right, at that x value. If a function has a 0 of even multiplicity, the graph of y equals f of x will touch the x-axis. For example, at this, like at this -4, at that point. And our last example, which is the graph of h of x equals x squared minus 2. So we're going to set each piece equals 0, x squared equals 0. That's just going to give me x equals 0, and this has an even multiplicity because of the squared. So that means it's touching at 0. And then we have x minus 3 equals 0. Solve for x, so that's going to give me x equals 3. And this should be crossing at 0 because it's an odd multiplicity. So it's going to be crossing at 3. Okay, let's look at our options. If we look at option A, it's crossing at 0 and crossing at 3. Does not work. If we look at example part C, it's touching at -3 and crossing at 0. We're looking for touching at 0 and crossing at 3. That doesn't work. If we look at D, we're crossing at 3 and touching at +3, the opposite we're looking for. So the correct answer has to be B. Since we're touching at 0 and crossing at 3, our correct answer is B. Hopefully this helps you understand how multiplicity works when we're dealing with finding zeros of a polynomial.